When you're working in a field that involves computer sciences like programming, networking, or information technology, it's important that you are capable of being able to convert numbering systems. So take a value in one numbering system and convert it to the comparable value in another numbering system. So what I'm going to be demonstrating to you in this tutorial is how to convert a decimal number into a binary number. We do this by using this table that you see here on the screen. It's an 8-column table that also has 3 rows. And in the first row, we're going to place the powers of 2. So I'm going to start in the far right-hand column there, column number 8. And I'm going to just put in 2 to the 0 power. Then I'll move over to the next column, put in 2 to the first power. Then 2 to the second power. 2 to the third power. 2 to the fourth power, 2 to the fifth, 2 to the sixth, and then 2 to the seventh power. So this table is going to represent 8 bits or an octet of an IP address or a subnet mask. Remember, an octet is a grouping of 8 bits. And so we've put in, starting with 2 to the 0, then each of the powers of 2 all the way up to 2 to the 7th power. So that's our first row, the powers of 2. The second row then is the decimal value row, and in this row what we do is we put in the conversion of each of the powers of 2 into its decimal equivalent. So 2 to the 0 power is 1 in decimal, 2 to the first power is 2 in decimal, 2 squared is 4, 2 to the third power 8, 2 to the fourth power is 16, 2 to the fifth 32, 2 to the sixth 64, and 2 to the 7th, 128. So those are each of the decimal values, the decimal representations of each of those powers of 2. If you didn't know the powers of 2, it's really not difficult. If you look at how this works, the decimal row starting on the far right-hand column, column number 8, as long as you can remember that that is the value 1, 2 to the 0 power is the number 1, then as you move to the left, you just simply double that number each time. So 2 is twice as much as 1, 4 twice as much as 2, 8 twice as much as 4, etc., etc. So that's basically the table that you need to set up to be able to make this conversion from decimal to binary. Now, the decimal number that I'm going to select for our demonstration here is the number 255. This is a number that's commonly found in subnet addresses, so I think it's a good idea for you to see what that looks like in its binary version. And we're going to put the binary version, or the binary information, the ones and the zeros, into the last row. So you can see that row is labeled binary digits or bits, and we'll place either a 1 or a 0 in each column, which will identify whether or not we're able to use a particular decimal value, the value above it in each column. When you are doing the conversion process, you want to work from the left to the right as you analyze each of the decimal values. For instance, we've got our starting number, the number that we want to convert, 255, and I want to look at the decimal row and go from left to right, highest to lowest, and see what is the first value there that I can subtract from my current number. So when we look at 128, that is less than 255, so obviously we can subtract that from 255. Now, to indicate that I can subtract 128 from 255, then I put a digit, a value of 1, into the column underneath of 128. So that's the binary representation that says that I am able to take or subtract 128 from 255. Then I do the math. I subtract that 128 from 255, come up with the remainder of 127. Now I'll repeat that process for each of the times that we end up with a remainder until we get to a remainder of 0. So now my current value is 127. I want to look again at the decimal value row and see what is the highest number, working from left to right, that I can use and be able to subtract from 127. Of course, that number is the number 64. So I place my 127 at the top. I identify 64 as the value I can subtract from it. I place a bit underneath of that value in the binary digits row, and then I go ahead and again perform the math, subtract 64 from 127, and I come up with a result or a remainder of 63. Just keep on repeating that process now. We've got a remainder still, 63, so we want to identify what can I subtract from 63. So we'll start with 63. We'll identify that 32 now is the highest value in the decimal row that I can subtract from 63. So I put a 1 into the binary digits row, I do the math, subtract 32 from 63, and we have a remainder now of 31. Again, I'll take that remainder, 31. I'll look and see which is the highest value I can subtract from it. It's 16. I'll go ahead and put a 1 in the binary digits row, and then do the math, subtract 16 from 31, and I get a remainder of 15. Take that remainder, 15, identify which is the next value I can subtract from it, and of course that's 8. We'll put a bit then in the 8 column in the binary digits row, and then do the math, subtract 8 from 15, and end up with a remainder of 7. So what can we subtract from 7? The highest number in the decimal row would be 4. We'll indicate that we're using 4 by putting a 1 in the column underneath of 4. Then do the math, subtract 4 from 7, get our remainder of 3. Take that remainder, figure out which value in the decimal row I can subtract from it. Of course that's 2. We'll indicate we're using the 2 with a 1 bit in the binary digits row under the column of 2, and then finish off the mathematical process here of 2 being subtracted from 3 and receiving a remainder of 1. We take that remainder of 1, again, we can see that 1 now is the value that we can subtract from it. And no other values in that decimal row could be subtracted from 1. So we'll go ahead and put a bit, turn on the bit there, put in a 1 for the binary digit to represent that we're using the decimal value 1, and go ahead and subtract it from our 1. Now we come up with a remainder of 0, so now we have completed the process. When you look now at that binary digit row, you'll see it is a sequence of contiguous 1s there. It's 8 1s, and that is the binary representation of the decimal value 255. So every time you have a 255 that you see in a subnet mask, the way the computer sees that is a contiguous collection of 8 1s.